Okay, so now, okay, let's look at our starter questions today. So what formula relates the sides of this triangle? What formula would it be? Since it's a right triangle. It's the Pythagorean, right? Okay? So that'd be a squared plus b squared equals c squared, correct? Now what would happen if what would happen to side C if gamma got bigger? C would get bigger, right? Because the bigger the angle, the bigger the side it cuts. And then what would happen to side C if gamma got smaller? It would get smaller as well. All right, that should be pretty intuitive. Okay. All right, so law of cosines is just a little tweak on the Pythagorean theorem. Okay, it accounts for the right angle in the triangle getting bigger or smaller than it normally is. The law of cosines is as follows. Just like the law of sines, it works on any triangle. Now, the nice thing about law of cosines, though, is there is no ambiguous case. There's no, okay, depending on if this is shorter than this and longer than this, I have 1, 2, or 12 triangles or what? Okay, actually, there's not 12. I'm just kidding. But you get what I'm saying, right? Okay, so the nice thing is that there's no ambiguous case, okay? So, the law of cosines basically is this. So, it's c squared equals a squared plus b squared minus 2ab times the cosine of gamma. Okay. Now, you might also see it now written as a squared equals b squared plus c squared. Wow, this is really small. Minus 2bc times the cosine of alpha. Or b squared equals a squared plus c squared minus 2ac times c times the cosine of beta. Okay, those are your three equations for the law of cosines. Okay. Now, and how to remember to keep those three equations straight. Okay. Okay, notice here it says, please note that each version starts with the side and ends with the angle that created that side. So notice on our main one here we have c squared, we have c here and gamma here. We have a here and alpha here, b here and beta here. Okay? Okay. So why is it minus 2ab cosine gamma? You know that's minus? Okay, so if you think about the distance formula, right, because that's what we're trying to find our distances, right? The distance is like x minus, or x2 minus x1 squared, da-da-da-da, okay? And so that's where that minus comes in, okay? Because, again, it's just a variation on, well, on the Pythagorean theorem, but also on the distance formula as well, okay? All right, so now the triangle inequality states that the sum of any two sides of a triangle must be longer than the third side. Good. Okay. Okay, so the easiest way to check this is the sum of the two short sides must be longer than the third side. All right. So now determine the number of triangles with the given parts.
B plus A. Wait, what if they equal to each other?
So what if they equal to each other? Is that a triangle? That is not a triangle. Okay. Excuse me. Okay, what about part B? Triangle? Yeah, because B plus C is definitely greater than 10. So yep, we got a triangle. Okay. All right, now.
Why does it say determine the number of triangles? I thought it was.
Well, because of this one right here. Yeah, so if it's side, 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 that's gonna be one triangle. What's the ambiguous case for law of sines? Angle, yeah, side, side, angle, or angle, side, side. Okay. Now, what about this one here? Okay, why do you say no?
It's 190 degrees.
Oh, okay. Yeah, that would kind of screw us up, right? The angles have to be 190, so that is a no.
92.
Okay,
Price?
sir.
Where do you want it?
Oh, you know what, just put those, okay, so now, there are procedures outlined in the section for cases of angle, side angle, side angle, side, and side angle to side, okay? So we've done pretty much all of them, all right? And now, depending upon what you're given, okay, you need to determine whether you're gonna use law of sines or law of cosines, okay? And generally, the rule is this: if you have an angle and its corresponding side, you'll almost always use law of sines, okay? Because law of sines is a little easier to do than law of cosines, right? Law of cosines, there's a lot of room for a lot of, of steps where you can make mistakes, okay? So, but there's sometimes when you're gonna have to use the law of cosines, depending on what, again, it depends on what we're given. And the more you practice with this, the more you'll be able to see how it works, okay? All right, so let's solve this triangle now, using the given information, okay? So we've got an angle and two sides. So now let's draw a triangle here. So we know alpha is an obtuse angle, so we're going to just draw, okay, something like that. Yeah, this one bad thing about this one, though, is I can't straighten my lines out like I could with my other one, okay? So this is angle alpha right here. All right, so this is opposite of side A. Wow, that is just a really bad triangle. I'd really like to be able to straighten that out. I'll work with this a little more. Okay, so now we'll just make this side B here, which makes this angle beta, and we'll make this side C here, which makes this angle gamma. Okay, so we're given alpha's 121, so we know this one, and we know side B, and we know side C. So that is angle, side, angle, okay? Now, since we don't know an angle and its corresponding side, or side angle, what did I say? That is side, angle, side, okay? But now, since we don't know an angle and its corresponding side, we can't use law of sines. So now we have to use law of cosines, okay? So we need to determine whether we want to solve for B or C or A. I mean, sorry, beta or gamma or A. So let's solve for side A, okay? So the law of cosines corresponding with that then is A squared equals B squared plus C squared minus 2 times A times C, no, so 2 times B times C, sorry, times the cosine of alpha. Okay, and now since we know alpha, B, and C, we can. This is just a plug and chug. Okay, but remember that this is A squared. It's not A. And you have to take the square root of the answer once you get that. Okay, and please be careful on your calculators. Okay, because if you try to do it all at one step, you're going to get a parenthesis wrong somewhere and screw the whole thing up. All right, so we get 2.9 squared plus 3.1 squared minus 2 times 2.9 times 3.1 minus, times the cosine of 121.3. So make sure you're in degree mode. Okay? So now the way that I do this so I don't mess it up is I calculate this part first. Okay, I get an actual number for that, and then then finding this sum here is pretty simple, and then you take the difference of them. Okay. So let's go ahead and do this. So start help me out here. 5.2. What's 5.2? Oh, so you got it all? So you just crammed it all in? Oops. Sorry. So A is 5.2. Good job, you guys. Now, since I don't have a calculator here, I'm going to have to trust you guys. Yeah, blob is 5.2. There we go. Okay, all right, so now we've got A. Okay, right, now, everybody hear Connor? Now we can use law of sines to find beta and gamma, okay? So we will go, let's see, now we want all the angles, so we'll go the sine of 121.3 over A, which we just did is 5.2, equals, I have to get rid of this. Write that here, 5.2. Okay, equals the sine of beta over B, which is 2.9, and you can just write this all at once if you want, over the sine of gamma.
Or you can just do 181.
Yeah, once you get there, correct. Over C, which is 3.1. Okay, so probably solve for beta here. So what do we get for that? 28.5?
On that,
Will somebody please verify for me?
is that the inverse sine times?
Right, so you say the inverse sine times 2.9, so get, again, you can probably get 2.9 sine 121.3 over 5.2, get that number, and then just take the inverse sine of that.
Oh, okay.
Okay. So what do we get? 28.5? Okay, so that beta is now 28.5. Okay, now, and again, so to find gamma, you can do the same process you just did, or like Connor said, you can just do 180 minus 28.5 minus 121.3, and we get gamma to be, say it again, 30.2. And there we go, I didn't put my degrees. And there you go. Our triangle is solved. So, law of cosines, not too bad. All right, now example 3. Okay, again, let's draw our triangle. And I don't know if this is acute or obtuse. Okay, first of all, is this a triangle? Do the two short sides, is there some bigger than the longest side? Yeah, easily, as a matter of fact. They're all pretty similar. So this is probably going to, it probably means it's going to be an acute triangle. So we'll just draw us, and gosh, man, my drawing sucks.
That one was pretty good.
Yeah, the bottom one was, but yeah, this one, the other one I used, it automatically straighten my lines out for me. Okay, so the longest side is B here, right? So we'll make this one B, which means this is angle beta. We'll make this one C over here, so this is gamma, and we'll make this one A, so this is alpha. Okay, so now, again, we don't have a corresponding side and angle, so we're gonna use law of cosine. So do you want to find alpha, beta, or gamma? And it doesn't matter. Beta. Gabby picks beta. Okay, so then we go. So let's first of all let's write the equation that goes with that. So we get b squared equals a squared plus c squared minus 2ac times the cosine of beta. All right. Now let's fill in what we know. So we know we got 7.1 squared equals 6.3 squared plus 6.8 squared minus 2 times 6.3 times 6.8 times the cosine of beta. So now we've got to solve for beta.
Wouldn't it be easier to just rearrange the problem before we place all the numbers in?
Personal preference. If you want to do that, Josh, knock yourself out. I got no problem with that. Okay? So now, first thing we have to do, we have to square everything out. Oops. So we got to square that, square this, and add those together, and then we're going to subtract that from both sides. That's the first thing we have to do. And here's where you need to be careful with your order of operations so you don't mess stuff up. Okay? A lot of times people will try and combine this sum here and this over here, that product over there. Bad, 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 because this is attached to it, so we can't combine them. Okay? All right, so we need to, okay, what's 7.1 squared? Just quickly. 50.41. Oh my gosh. Okay, gotta get used to this. Oh, other color.
Tell them your price.
50.41. Shut up, dude. I will knock you out. Okay, 6.3 squared.
That on tape, so.
Yes, it is.
Wait, we had 85.83. And that's half.
Oh, so the sum is 85.83?
Yeah,
Thank you, Al.
or 9.3.
9.3. Okay, so now minus, and then what's 2 times 6.3 times 6.8?
85.68.
What's that?
85.68.
85.68. Oh, gosh. Times the cosine of beta. Okay, so now we're going to subtract 85.93 from both sides. And that gives us negative 35.52.
Yep.
And that equals negative 85.68 cosine beta. Now what do I do? Yeah, good. Now I have to divide by negative 85.68. And then we take the inverse cosine of that. And what does beta equal eventually?
65.5.
Beta is 65.5? Okay. Now we use what, Connor?
Call sign.
Good man. Law of sines to find either alpha or gamma, and then you can do the 180 thing to find the other one. Okay. So we go, okay, the sine of 65.5 over b, which is 7.1, equals, okay, let's go gamma, the sine of gamma over c, which is 6.8. Okay. And eventually we get gamma to be what's gamma, Al? 60.6. And then alpha would be what? 53.7? That doesn't add up.
No.
No, yeah.
Or is it,
This is 65,
yeah, 53.9?
53.9. That I'll accept. Okay, there we go. Triangle solved. So a bearing of 80 degrees then is roughly right there, right? Because remember, bearing is from due north. Okay, and then a bearing of 240 is, let's see, 180, 240, so 60, so it's,
Oh, okay.
You go clockwise?
yes, kind of like that. Wow. Obviously the pilots were a little drunk.
Are you driving the plane?
Maybe. Okay. All right, so now, whoa. There we go. So there's our lovely triangle. Okay. All right, so now again we need to figure out the angles of our triangle. Oh my gosh, that is just so bad. Yeah, I think, okay, we're going to delete that part. Okay, so Andrea and Carlos left the airport at the same time. Andrea flew at 188 miles per hour on a course with a bearing of 80 degrees. Now again, remember bearing is from due north, okay? That's how you measure the bearing. Okay, so you start north and you go clockwise and that'll give you your bearing. And then Carlos flew at 240 miles per hour with a bearing of 210. So let's draw that up with my awesomely straight lines. Okay, so we'll do this part in red. So Andrea's bearing was 80 degrees, so it's roughly right there. That's where Andrea flew. Yes, I know, please, contain your applause. Until the end, right? One big applause at the end. Okay. So now Carlos is a bearing of 210. So again, remember, we start at north and we go clockwise, so he's gonna be roughly right here. There's Carlos. Okay? Now what we want to do is figure out the black side, the length. That's how far apart they are after 3 hours, okay? Let's write down what we know. So we know after 3 hours, if Andrea flew 180 miles an hour, she flew for 540 miles per hour, or 180 times 3. Okay, Carlos, he's a little quicker. So at 240 times 3 is, what was that, 720? That we said that was. Okay, so now we've got two sides, but now we need to find an angle. Okay? And the easiest angle to find is this angle right here. Okay, so now with this angle, all right, again, since Andrew's bearing is 80, we know this little part of our angle is 10 degrees. All right, and then we know from the x-axis to the y-axis is 90 degrees. And now since the blue line, Carlos is 210, we know this little part here is 30. So if we add all those up, we get 130 degrees for that angle. Okay, so now we've got a side, an angle, and a side. Now we're going to use the law of cosines. Okay, and we'll call this. We'll call this side D because that's the distance we want for after 3 hours. So we go D squared equals 540 squared plus 720 squared minus 2 times 540 times 720. Someone get this going on your calculator, please. Times the cosine of 130. Okay, so long story short, what does D equal? 1,144.5 miles apart. Okay. So everybody all right with that one?
Can we do
Good?
one big applause now?
Not yet. We're not done. Okay, so last type of problem that you'll see on your homework. Okay, we use the law of cosines and we generate the formula for the length of a chord. Okay, now alpha is the central angle. Okay, or it's the angle that forms the chord. Okay, A is the length of the chord and R is the radius. Okay, so we have A equals R times the square root of 2 minus 2 cosine alpha. Okay, so now example 5 says if each side of a regular octagon is 12 inches, what is the distance from a vertex to the center? Okay, so if we draw our octagon, here we go. You know, as a dry red guy, you think I could draw a stop sign a little better. There's our wonderful regular octagon. Now, the key here is the term regular because that means what? If I have a regular polygon. All sides are congruent and all angles are congruent. All central angles are congruent, okay? So now we're going to take from the center of our octagon here and we're going to go there and we're just going to form a little triangle, okay? Now, we know that the side is 12. Radius is what we don't know. It's what we want to find. Now, how do we find alpha? Yeah, okay. If I started here and went all the way around, I would have 360 degrees. And since we know all 8 angles are congruent, I can just take 360 divided by 8, and we get 45 out of the deal. And now we plug and chug. So we get A, which we know is 12. Equals R, which we don't know, so what we're going to have to find, times the square root of 2 minus 2 times the cosine of 45. We know the cosine of 45 is root 2 over 2, or in decimals 0.707. So if you double that, we get, what, 14.14? No. Sorry, 1.414. Double that for me. 7.07 doubled. Yeah, okay. So now we have 2 minus 1.414. Subtract that, take the square root of it, and then divide 12 by it. And we get R is, oh, cancel. R is 15, what was it, 15.7? Okay, and there we go. And that is in inches, so make sure that you write that correctly. All right, questions? All right, that is it.